Okay, so we're going to take a look at a few examples of functions and we're going to be asked to find the range of each. In our first example, we're finding the range of the function f of x equals 3x cubed, and a graph is really helpful to find the range. Go to your graphing calculator, or here I have graphed this function in desmos.com, and you can see that the function here has this S shape. There are arrows implied here on either end. You can see that this function always increases, and again our range is going to be the set of all possible output values or all y values. And as you can look at this graph, you see that there is no minimum or lowest point of this graph, so that means that our range will start from negative infinity. If we're using interval notation, we would say negative infinity, and then the graph increases and has no maximum, and it keeps increasing to infinity. So in interval notation, then the range would be negative infinity to infinity, also known as all real numbers for the range of this particular function. Okay, let's take a look at a different function now. This question asks, what is the range of the function f of x equals 4x minus 5 over the interval of x being between 1 and 5, include the 5 but not the 1. Okay, give your answer in interval notation. So let's graph this function, which is a line. This is f of x equals 4x minus 5. You may recognize that as a line in slope-intercept form. So I'm going to go down to my grid here. Now my domain is restricted, so between 1 and 5. So I'm going to go ahead and find what f of 1 is. And so that's 4 times 1 minus 5, which is negative 1. So I'm going to go to the order pair 1, negative 1 as a starting point to this line. But since I cannot include the value of x at 1, because this is a strict inequality here, you can see that I don't have an equal sign under here. When I go to graph this in my grid, this will be an open circled. So I'm going to go to 1, negative 1, and just put an open circle there. Okay. The other endpoint is at 5, so we can go to f of 5 and go 4 times 5 minus 5, which is 20 minus 5, or 15. Okay, that's going to go up here beyond my grid, but let's go ahead and let's see here. 1, 2, 3, 4, 5, and so 15 will be up here somewhere, and that will have a closed dot. We have to include that order pair because 5 is part of the domain of this function. And then of course the function itself is a straight line, so just join those two, and I'm doing this without a ruler, so you can see there. Okay, there we go. And so now let's look at the range. And again, the range is going to be the y values or the output values. So we look at range by looking at the lowest point of the graph, which is happening right here at this endpoint, 1, negative 1. And so my lowest y value is negative 1. And I have to put that negative 1 in parentheses because I have an open circle there. I am not including that, that value, negative 1, in my range. Okay, and then the highest value occurs here, of course, at the other endpoint, at which point our y value, our output, is 15. And so, but that one isn't included, that order pair is included in the function, so I'm going to put a bracket, a square bracket here in my interval notation. So that will be the range of this function. Let's take a look at one more example. Okay, and this example is, what is the range of the function f of x equals x squared minus 1 over the interval x is between negative 1 and 3. Include the negative 1 but don't include the 3, right? And give your answer in interval notation. Again, let's graph the function, and then I recognize this, and I hope you do too, as a parabola. It's a quadratic. You have that x squared. And again, let's find f of negative 1. So f of negative 1 is negative 1 squared minus 1, which is 1 minus 1, or 0. And we're going to include that order pair in the parabola because of our equal sign there, right? So negative 1 and then 0. So I'm going to put a closed dot there. Okay. Um, Now this parabola, because the coefficient of the x squared is a positive 1, that's um, understood that our coefficient is a positive 1, then this parabola is an upward opening parabola. Okay? And its vertex is going to be at 0, -1. So when I take a look at some order pairs that are on this parabola, of course we have the -1, 0 that we just found there. And I'm just going to put in a few values of x so you can kind of get the feel for this shape. Again, if you have access to your graphing calculator, you could go to your graphing calculator and do that there as well, right? So let's see, 0, -1, okay, and then f of 1, 1 squared minus 1, which is 0, and then f of 2 is 2 squared minus 1, which is 3, and then f of 3 is 3 squared minus 1, which is 8. So the parabola goes from -1, 0, then down to 0, -1. Then it comes back up to 1, 0, 2, 3, and then finally at 3, 8. But at 3, 8, we have to put an open circle because x is not in the domain, right? There's no equal sign here. So this looks like this. Oop, little piece of the parabola there. Looking at the range, again, we're going to go from our lowest point to our highest point, and we're going to describe the outputs or the y values. Lowest point to highest on your graph, okay, and then describe y. So the interval that we're describing is in terms of y. So the lowest point is definitely right there. There's our lowest point, and then here's our highest point, right? So our lowest y, move this up, our lowest y value is at -1, and we include the -1, so we put a square bracket on it because that's part of our graph, right? There's a closed dot there. But then our highest point is up here at 8, 3, 8, right? So the highest y value would be 8, but you have an open circle there. We do not include that 8 in our range, so that's why we're going to put the parentheses. Okay, I hope that helps.